Do we record every drop or just till it turns pink and keep it going?
You just do the volume at which it turned pink and stayed pink. Okay? Okay, I'm recording this, guys. Okay, so acetic acid is HC2H3O2, and you're reacting with sodium hydroxide to make sodium acetate plus water. Okay? And you're doing that to determine how much acetic acid is in the reaction. But before I do that, I need to know the concentration of my sodium hydroxide. So I'm doing something called KHP, which is not potassium hydrogen phosphorus. It's potassium hydrogen phthalate. And it is KHC8H4O. Okay? So that's this right here is the phthalate. Okay? And so KHP plus the sodium hydroxide goes to form KNaC8H4O. Whoops, that's 4 plus water. Okay? And the relationship, these are all balanced. What's the relationship between the acetic acid and the sodium hydroxide? What's the ratio of moles? 1 to 1. And the KHP to sodium hydroxide is also 1 to 1. Okay? So again, 1 through 4 can be answered from the first page of this. Okay? So I'm going to start with number 5. All right, so number 5A is the volume. Okay? Yep, 5A is the final volume minus the initial volume, but I need it in liters. Okay? And so for all of these, you're going to have 2 answers until I get to D, and now my average. So this is the volume it turned red or turned pink. This was where my burette started.
0, right?
Yes, but it doesn't have to be 0. Okay? So what you can do is that if you're less than 25 milliliters on the first titration, you don't need to refill it unless you're going between KHP and vinegar. At that point, you want to refill it. Okay? The vinegar may take more than 50 milliliters. Okay? Hold on. On what?
Like you saying, so for like the first experiment may be 0, but the second one might be different.
Yes. Your VI may be different. Okay. Number 2 is the moles of KHP. If I weighed out solid KHP, how do I find the moles of it? If I weighed out solid KHP, how do I find the moles? Mass divided by molar mass. So the mass divided by the molar mass. And so this was measured. Okay? For both, you're going to do 2 titrations of this one and 2 titrations with the vinegar. C is the moles of sodium hydroxide. So given this relationship, which we just said, was what? Between the KHP and the sodium hydroxide is 1 to 1. Okay? So therefore, what should be the moles of sodium hydroxide? Well, it's going to be equal to, no, the moles of KHP. From 5B. Okay? Let me rewrite that. Okay? All right, D is the molarity of the sodium hydroxide. How do I find the molarity of something?
Is the I forgot.
It's the moles of sodium hydroxide per liter of solution. So that's going to be 5C divided by 5A. And I'm going to then average the 2 5Ds. Okay? All right, so this is KHP and the sodium hydroxide. Okay?
What does that say for C?
That the moles of sodium hydroxide is equal to the moles of KHP, which basically means it's equal to number 5B. Okay, there's no calculation. Okay, for number 6, this is the vinegar and sodium hydroxide titrations. So 6A, again, is the volume of sodium hydroxide, which is still going to be the final volume minus the initial volume. Okay? 6B is going to be the moles of sodium hydroxide. So sodium hydroxide is a solution, so how do I find the moles of it? Nope, that was using mass. I'm not measuring the mass of sodium hydroxide. So last semester we learned 3 ways to find moles, right? Mass divided by molar mass, the ideal gas law. What's the third one? Hint is the formula's on this slide here. It's the molarity times the volume. So it's the molarity times the volume. So this is going to be the average of 5D, and this is going to be 6A. Okay? 6C is going to be the moles of KHP. Okay? So again, looking back at this the balanced reaction, if I have these many moles, how do I find the moles of KHP? I have now the moles of sodium hydroxide. How do I find the moles of KHP? What's the relationship? 1 to 1. So basically that means that that's going to be equal to my moles of sodium hydroxide, or equal to 6B. Yeah. All right, 6D is to find the mass. I really don't want equal signs there. Is to find the mass of my acetic acid. So if I have the mole, I'm sorry. This is acetic acid. Sorry. If I have the moles of acetic acid, how do I find the mass of it? Nope. How do I go from moles of something to mass of something? Multiply by its molar mass. So it's going to be the N of HC2H3O2 times its molar mass, which is going to be 6C times the molar mass. All right, 6E is the last one, and I'm going to find the percent acetic acid in the vinegar. Okay, so that's going to be the mass, the percent is going to be the mass of acetic acid over the mass of solution. Okay. And the mass of solution, it tells you that we're going to assume the density of vinegar is 1. Gram per milliliter. So therefore, how do I find the mass of solution? If the density is 1, what did I measure out of vinegar? Huh? What measurement of vinegar do I make? Look at your procedure. What do I measure out of vinegar? Well, but no, it says vinegar. What measurement of vinegar do I make? It's in the second part. Which milliliters is the unit of? Volume. So basically, because of the fact that the density is 1, my volume of vinegar in milliliters is equal to my mass of solution in grams. Okay? So this is going to be 6D, and this is going to be that. Okay? Times 100 to get into percents. Okay? So you're going to have 2 answers there again. All right? Any questions? You're doing 4 titrations altogether, 2 with the KHP and 2 with the vinegar. Okay?